Now we shall see about arrays. Arrays are the simplest data structure which we have, and in this lecture we will be mainly focused about one-dimensional arrays. There are basically two types of arrays. One is one-dimensional and the other one is two-dimensional. By using this basic data structure, I mean to say that arrays can be used to create those derived data structures such as stacks, queues, and the other data structure which we have. Later on we shall see one by one that what stack is, what queue is. As of now, just stick to what I am teaching about arrays. Once we get the concept of arrays, it will be very much easier for us to derive all those data structure and see that what are the characteristics of that, what are the characteristics of stacks, where they are used, why we should stack queue, why we should use stack instead of queue, and where queue is used. As of now, just stick to the concept of array first, then we shall see them. So now coming to this array, one of the most important characteristic of array which we have is that it is random accessible. Now whenever I say that it is random accessible, we should understand that what it actually means. It actually means that if you are given with an array, that means you have a collection of some elements which should be of same data type. Suppose you have an array of integer. So random access means with those collection of elements, you just want to go to a particular element, just pick it up and assign it to some other variable. That means that it is randomly accessible. You just, if you want to take that element, you can directly go and pick that element. Okay, so now this question that comes into our mind is that why arrays are random accessible. So suppose I am having an array of some elements like 9, 6, 5, 4 and 3. Suppose I am having some elements in an array. Now before going to that part of random access and all, we shall see that there are 2 points about arrays. Array indexing. So what array indexing is, that starting address, not the starting address, I mean the index of the starting element of an array. So there can be two possibilities. Either our array should start with 0, that is 0, 1, 2, 3, 4, or it can start with 1. And it can be any one of them. Either it can start with 0 or it can start with 1. Depending upon your implementation, you can go with any one of them. So we can also have, suppose if it is starting from 1, index 1, then we shall have something like this. Okay, so both of them are one-dimensional array, and now we shall see that how these are mapped into memory. So as I told you that they are randomly accessible, they are randomly accessible because of their property of contiguity. Means all the elements present in our array will take contiguous memory, contiguous location in the memory. Suppose I am having a memory like this, and so on. Memory, it is some, I mean, if you have a huge amount of memory and you just want to assign some memory location to your given array. Suppose your array is A. You are having an array A of element of size, suppose 5. You are having an array of element which size is of about 5 elements. So you are supposed to take this entire array and just put it into the memory. So now it will be just like this: 9, 6, 5, 4, 3. Always they will be contiguous. Okay, then there will be some other elements, irrespective, we are not bothered with that what are the rest of the elements there will be, but there will be some elements. Okay, now if we know the starting address of our array from where it has started in the memory, and we know the size of each and every cell that it is occupying in the memory, then after doing some mathematical computation, we can easily find out that which element we are supposed to find. Suppose I have 100 and suppose my memory is byte addressable. Later on we shall see that what is byte addressable and word addressable. As of now, just think that our memory is byte addressable. Maybe it can be word addressable, but depending upon that we shall see that how byte addressable and word addressable thing is changing. Suppose I am having the size of each and every cell as 1 byte. So if I multiply this 1 byte with each and every cell, then how many number of cells do I have to cross to reach this element starting with the starting with the address of 100, if I do that calculation, then I can directly jump into this element 4 without traversing everything. I can directly get that element without actually traversing this. So this is the feature why it is called as random access. Okay, now we shall see that how this entire thing is working. Suppose we have an array and there are some elements, maybe one more. Okay, and we have an array A of size, suppose we have 5 elements here, and those elements are 0, 1, 2, 3, 4. Just for the sake of simplicity, I am taking this small example, and each and every cell is of 1 byte, and they are starting from index 0, 1, 2, 3, 4. Now, in order to go to this second element, not this element with index 2, just focus here what I am saying. If in order to go to this element which is having an index 2, how many cells do I have to cover if I am starting my traversal from here? I will have to cross these 2 cells, isn't it? Suppose I want to go to this element which is having an index of 3. Then how many cells do I have to cross in order to reach this element is same as the number of, which is same as the index. If I want to go to this element having an array index of 3, I will have to cross these 3 cells. So in general, we can easily write it as, if my I is the index, in order to reach this I have to cross I number of cells. Okay, I number of cells I will have to cross, and suppose as I am telling you that the size of each and every cell is 1 byte, suppose I declare it as a variable size. Now this is pretty generic, that can be 1 word or 1 byte, irrespective of that. For the sake of your simplicity, I am telling that it is size. So I will have to multiply it with size. I into size I will get here. I will directly jump into this element with an index 3. Here 3 is I is equals to 3. Now if my array is starting from an address 100 in the main memory, then I will have to add it. So this is the way how we can represent our one-dimensional array in the memory. Okay, so we can write it more precisely as AI. Suppose I want to go to this element. Okay, so how can I do it? This element's index is 2 into size, as I told you that size is 1 byte, I will multiply 1 plus the starting index is given as 100, I will just add 100, as simple as that. So this is 2 plus 100, which is 102. See, for this small example, it is very much easier for you to intuitively see that if it is 100, then 100 plus 0, 100 plus 1, 100 plus 2. But what if my array size is 1000 or 1050 and your array index is starting from 998? Then what will you do? You will just make a paper and then will get all the calculations done. It is not possible. And moreover, if you are preparing for some competitive exam, then it will be a hectic job for you. So if you can derive this, then it will be very much easier for you. Okay, so this is the way we can write our if we want to get into some element, then the basic method is this. Now the obvious question will come into your mind that while you must have done some coding, I'm thinking that you must have done some type of coding. In C programming language, in order to go to some element, we never use this formula. We never use this formula. We just directly used to write as A of 0 is equals to 1, isn't it? This A of 0 is equals to 1 is at user level. Our operating system is going to do this calculation. Once your compiler has compiled the code, it is the job of the operating system to do this necessary calculation for you. This is for user. Otherwise, if we have to write this for each and every, suppose each and every term, then suppose you are multiplying a matrix of 64 cross 64. Will you do this calculation all the time for allocating some elements in the array? It is not possible. Our operating system is going to do this. And another most important thing is, now the next important thing is that you can see this formula, and one thing for sure, don't by heart any formula, because once you know the concept deeply, you can easily derive this formula. So no need to by heart anything. Especially in computer science, there is nothing to by heart except the concepts. Once you get the concept, you can easily derive it. Okay. Now the next important thing is that, as I told you, that arrays can start from 0 index as well as from index 1. So now we shall see that how this formula, or how we can access an element if its starting index is 1. Okay, let me write it. Suppose I have an array of again some 5 or 4 elements, maybe 5 elements. Now the starting index is 1, not 0. Suppose we have an array, and maybe elements can be 9, 6, 5, 4, 3. Okay. Now suppose I want to go to this element 4 with index 4 itself. Now in order to go to this element 4 with index 4, how many elements will I have to cross in order to reach this cell? There will be 1, 2, 3, that is exactly 4 minus 1 cells. Isn't it? Exactly 4 minus 1 cells I will have to cross in order to reach this cell with an index 4. Suppose I will have to go to this, suppose I want to go to this cell which is having an index 5, then how many cells do I have to cross? It is 1, 2, 3, 4. Again this index minus 1, 5 minus 1. So in general I can write that if my index is denoted by I, then I minus 1 are the number of cells which I have to cross to reach that particular cell. And if the size of each and every element is again can be written as size, suppose I am having a variable size, then again I minus 1 into size, plus suppose I am having a starting index of 100, I mean starting address in our memory for this array A is 100, then I will just add it. This becomes the basic general formula. So suppose I want to go to this element 3 with index 5. Then how I can reach there is, suppose I write it as like this, I5 it is, so it is 4 into 1 plus 100, it is 104. You can easily check it, 100, 1, 2, 3, 4. Oh, 100 plus 1, 2, 3, 4. Isn't it? I have done something wrong, I think. 5 minus 1 into 4 plus 100, 1, 2, 3, 4. 100. Oh, it is 100. This location is 100, so 101, 2, 3, 4. This location will have 100, so 100 plus 1, 100 plus 2, 100 plus 3, and 100 plus 4. So this is 104 location. So in this way you can derive, if you are given with an array, you can see that in this way, if you are given with the index, then you can directly, with the help of this formula, you can derive that what will be the address of that particular element in the memory location, given that your starting index is given and your size of each and every cell is given, and also that array index is given, that whether it is starting from 0 or it is starting from 1. Okay, now we shall see that how two-dimensional array is mapped. This is all about one-dimensional array, and now we shall see that how two-dimensional array is mapped in our memory. Okay.